Hi everyone, welcome to my honors capstone presentation. I did a MDP with a sponsor company outside of school on NLP in medical document retrieval. I am particularly interested in machine learning when I was at the MDP showcase. So when I came across this project, I just thought, well, it was really interesting to see how AI could be applied in medical search engine. And so I applied and fortunately got accepted. My team consists of 7 people, and my sub team has 3, who are Ashwin, me, and Joel. And I want to say a special thank you to Brian, our academic sponsor, Kevin, and Daniel, our sponsors. So let's dive deep into the detail of my project. The sponsor company is a well-known search engine provider with a large database with billions of records. It is authoritative sources for students and professionals and has been providing powerful and efficient search for medical papers. However, it is really difficult to compose search queries with the SQL-like requirements. You actually have to hire professionals to do the search for you in order to find particular documents. And due to its audit algorithm, sometimes it can still give inaccurate results. So the question comes down to how to improve with AI. It is a really open-ended question, and it was also the most difficulty I had come across while doing this project. We spent a lot of time to just reading papers and coming up proposing solutions, and then getting rejected or questioned, and then having to come back and come with better solutions. Eventually, we landed on similar document suggestion with user-selected results. Um, it is essentially a recommender system with unsupervised learning. What we want to do is similar to it can be explained by the diagram. So, for example, Homer bought a Dovecon energy drink, and we want our algorithm to see it and thought Dovecon energy drink, the franchise T-shirt, could also be his interested and recommend this T-shirt to him for him to buy. And similarly, we want our algorithm to see that a user has searched with a query and selected a result that he wants, and we want to suggest similar documents to him for him to view. This could largely reduce the time user has to spend just looking at more documents and searching. We started with Dataset Collection. We have the corpora from sponsors provided to us, and we also reached out to find popular research databases composed by professionals in clinic NLP for their researches. We did this for comparison and evaluation of our own method. I can't go into much technical detail because it is a sponsored project, so I'll just mention what we did. We looked at deep learning in NLP. Because it has generally high performance than traditional solutions. NLP tasks include document summarization and classification, and that is exactly what we want. We then looked at popular deep learning models for NLP, including Word2Vec. We also looked at transformer-based ones like BERT and ExcelNet, and transformer means that we have a bunch of input, but we can filter out the irrelevant data, and the output would be, for example, a classification, a vectorization of the information that we most dearly need. And eventually we did a document to vector vectorization. It is really close to word vectorization. Essentially, we represent a document as a numeric vector, and that can best describe its characteristics. And we cluster vectors based on vector cosine similarity. We can then measure accuracy and compare with the old algorithm in use as the baseline. On the bottom right diagram, you can see example of what it would look like. Here it is actually a word vectorization, but you can just imagine each word as a document. A document vector can have much higher vector space, but it all comes down to looking like this. Um, Essentially, the larger the vector multiplication is, the more similar it has to be. And each coordinate can correspond to, for example, a most frequent word or a characteristics that we have set up before we start to train with the model. And the performance evaluation, we did two methods. First, we cluster all the document embeddings, and we did textual coherence and grantee linkage evaluation. Textual coherence is essentially evaluating the textual information. We calculate JST for the entire corpus, and then for grant linkage, it is evaluating how many similar documents have the same grant within the whole cluster. And our result shows is really promising. We have a 2% outperformance than the old solution from our new clusters, new clustering solutions. And for the grantee linkage one, we have a higher precision and faster convergence based on the diagram. Our conclusion then just comes down to, we have achieved better similarity for our retrieved documents than the old solution. We have very low cost of evaluation because our algorithms are all automated instead of expensive human rating. And we have great scalability for large corpus because we started off from a small sampling of the corpus, and then we extend our algorithm to the entire corpus. It could take 1 day of training and 1 day of embedding, but that compared to just evaluating by hand, it is very, very efficient. And it does not require extra effort. As for the future challenge, is also what I would love to do if I had the time. We did explore a little bit of query dependent method that for similarity result, we like trained and applied another ranker when after we have the similarity results, to make it better and more closely related to the query that the user input. But I believe there can be other ways to integrate query information in our similarity result as well. And as for the rankers, we might have even better solutions. For example, telescoping, which is basically have a ranker for a separate portion of the similarity results. For example, top 10, top 20, top 50, so that the result is not biased towards any one of the ranker. And then we learn to rank. We can also explore the learn to rank rankers on the market instead of training a new one by ourselves, which is definitely not as good as those ones. And I want to thank you for viewing this video. I am extremely grateful to have this opportunity to do this capstone. I would definitely carry this industrial experience with me in the future, into my career, into my later life. It was very valuable to be able to learn how to coordinate with a large team and work in a smaller team and maintain a healthy work-life balance. As the pandemic started mid-project and separate us apart, I did grew a lot and had great experience to work from home, to learn to work from home and stay efficient and stay active. Thank you.